Okay, let's talk about intervals and instants. And let's get a pen that works. Here we go. Intervals and instants. This is pretty straightforward, but it's going to lead us into how to use delta notation, which we discussed a bit yesterday, and then eventually into rates of change. So let's start with a number line. And let's also have below the number line a timeline. Okay, so the timeline is kind of an interesting thing, right? If you think about it, we could say that this is 0, 1, 2, 3, all the way up. Okay, this is time going by. And something that we know about time is that time only ever moves in one direction, right? Time only moves forward. And we would say it is a scalar value, only moves forward. Whereas if above this, we have a number line, which is going to represent a position in space. Okay. We can imagine that we have, a person, and at time equals 0, right there, they are at position 0. Okay. And now this person could do some stuff. They could like come over here, okay, and stand over here at some time later. Let's say t equals 7 seconds. Okay, they moved over to here, and this is plus 7 meters. Okay, so at 7 seconds they're there. So 1. Okay, and we could say p equals 7. And then let's say they turn around and they like zip all the way back over to here. And they're there at like 10 seconds. And for some reason they change color. That's a -7. Okay, so now they're here, and p equals -7 meters. Okay, so the first thing to note here is that time is a progression of instants. Okay, time is a progression of instants. So what does that mean? Well, let's define what we mean when we say an instant. An instant is an infinitesimally it's infinitely small. Maybe I should just say infinitesimal, whatever. Infinitesimally small moment. Okay? In fact, an instant in time takes up no time itself. You might also call it a point in time. A point in time. Okay? So all of these are instants or points in time, right? Every single progression along here is considered to be an instant in time. Okay? An interval in time is the difference between 2 points in time. Okay? An interval is the difference between 2 points in time and actually it could be in space as well, but we're talking about time right now. And we use delta notation to talk about intervals. Okay, so looking here, this could be one interval in time. And this could be the second interval in time, right? And if we think about it, this is made up of 2 time intervals. One where this object is presumably moving right the whole time, and one where it's presumably moving left the whole time. Okay? So delta notation, then, how do we use it? So let's call this interval A and call this interval B. Okay? So we might say delta t for interval A is equal to t A sub f minus t A sub I. So what that simply means is my final time for A, subtract my initial time for A. So time-wise, this is a pretty easy one. It's just, my final is 7 seconds minus my initial, which was 0 seconds. 7 seconds have passed for interval A. Do the same thing for B, but you'll see a slight difference. We still can use the same type of notation. By the way, how we're actually writing this out might change depending on who your teacher is or where you take physics, but the concept is the same. The idea is the same. So this ends at 10 seconds, but it started at 7 seconds. And that interval was 3 seconds long, okay? So the total is these two intervals added up together, but this was a 10-second interval, and this was a 3-second interval. So there's the difference between instances and intervals in time. All right, let's do the same thing for our changes in position. Okay, so a change in position has sort of like a corollary to what we've just done here. So position is like an instant in space, if you want. It's your current like place on the number line, and we call a change in position a displacement. Okay, so change in position is known as displacement. So let's just go up to our number line and have a look at our changes in displacement. So we've got one change in position here. So we just call this delta D. And even though we're talking about position, we're still just going to use this notation, df minus di. Okay. So in this case, it'll be 7 meters subtract 0 meters, and we went a displacement of 7 meters. Notice how it's positive because we're on a number line. The left and right are just indicated by positive and negative values. Okay, so 7 meters would indicate 7 to the right. So we would say for delta D A, again we have dAF minus dAi, 7 minus 0 meters, and total change of 7 meters, right? So these are our instantaneous positions, and the interval between the positions is called displacement. Make sense? Pretty straightforward. And let's talk about the second interval. It's a little more interesting. Notice for delta notation, it's always final minus initial. So we have to change it a little bit, right? So for B here, dBi, the initial position now is over here at 7 meters, and dBf is actually equal to negative 7 meters. Okay, so this person actually went 14 meters to the left. So using our formula, it should pop out a value of negative 14 meters, right? 7 to get back to 0, and 7 more to get to negative 7. Let's see if it does. So negative 7 minus 7 equals negative 14 meters. Okay. So now I want to talk about something else. Rates of change. Basically, this is measuring change over a time interval. Okay, measuring change over a time interval. We'll just use a quick introduction with something you're probably quite familiar with. How about let's talk about this, because this is a rate, 100 kilometers per hour. This is like the speed limit on most Canadian highways. Okay, and what it simply means is your position will change by 100 kilometers every hour as you drive down the highway, right? That's what it means. If you go that speed limit, of course, right? If you stick to that speed limit, that's what it means. Okay? After 1 hour, you'll go from 0 to 100 kilometers. If you keep going, after 2 hours, you'll be at 200 kilometers, and so on, right? So this is a rate of change in position. You change by 100 kilometers every hour. Does that make sense? Pretty simple, right? So what are we talking about then? Well, Speed is a rate that we're sort of familiar with, and that's what we're talking about. And that is just simply this. It is distance divided by the amount of time it took to go that distance. Okay, if that makes sense. So it's the rate of change in distance versus time. Let's do a quick example to make sense of what that means. Let's say you took a drive in your car and you went like 538 kilometers and it took you 3.9 hours. Ooh, you're driving fast. Okay, so you're going 538 kilometers per 3.9 hours. So what we're going to do to get it into a rate is we're just going to figure that out in terms of what happens every hour. So we're just going to do this ratio or reduce this fraction or essentially divide 538 by 3.9 and see what we come up with. So by this math, it looks like you'd be going about 138 kilometers per hour. Okay. Now this is actually giving me the average speed. Okay. It's giving me the average speed because I have absolutely no idea whether this car was traveling faster at some instant in time, whether it was traveling slower at some instant in time, or whether it was stopped, or whether it was like, you know, who knows, maybe it like drove in the ditch and maybe it like did a whole bunch of different things that we don't know about. So what we call this is the average speed. Just saying that it's as if it did this. We don't know for sure if it really did this or not. Okay. So this is a rate of change in distance. So we're going to just change this a little bit. We're going to talk about what is the rate of change in displacement. And we have a word for it, and it's called velocity. All right? So it's just a little different than this, okay? And it looks like this. It says velocity is delta d, right? Change in position, which is displacement. So it's displacement divided by change in time. So we've already actually like solved the velocity, or we've solved what we need to put into the velocity for part A and part B of our little you know, journey here, right? This person goes slowly to the right and then fairly quickly to the left. So let's see numerically what we get in terms of our velocities for each of these. Let's talk about A first. So delta D, well, that was, again, if you remember, 7 meters minus 0 meters divided by 7 seconds minus 0 seconds, and that will come out to be 1 meter per second. And then we'll look at the velocity for part B. So it's a little bit different. We had negative 7 meters minus 7 meters. Okay, and then time-wise, we have 10 seconds minus 7 seconds. We have negative 14 meters in 3 seconds. And we get about negative 4.7 meters per second. So you can imagine then, right, that this person traveled to the right slowly and then ran really fast to the left. Okay? We can figure out a few more things too. We could also figure out the average velocity for the whole trip, which is going to be a different value still. So VAV is simply the overall displacement divided by the overall time. All right? So the overall displacement is final position minus initial position, which, you know, really they started at 0 meters, divided by the total time that the trip took, in this case, 10 seconds. So we get negative 7 meters divided by 10 seconds, and you get negative 0.7 meters per second. So we can pull multiple different numbers out of the same motion, and they all mean different things. And you as a physics student have to understand all these differences and what we mean by average and what we mean by instantaneous and what we mean by all of these things. And the last thing we can do with this, just for comparison's sake, is we can actually figure out the speed for that trip. Let's do the speed for the whole trip. So this person went 7 to the right and then 14 to the left. So that should be what, 21? So they went 21 meters total, and that took them 10 seconds. Their speed, a different number still, is 2.1 meters per second. Notice that speed will never have a negative or a positive. It has no direction. Okay? So these are all applications of various rates. Speed is a rate, velocity is a rate. Okay? I think we'll leave it at that for now.